advantages and disadvantages of K-map method? Can anybody tell me? What are the advantages and disadvantages of K-map method? Yes? Can someone explain me what are the advantages and disadvantages of K-map method? Yes, quickly. Yes, Sahil. Yes. Can anybody explain what are the advantages? Yes.
So it minimizes Boolean expression without using various Boolean theorems and computations.
Okay.
And it also minimizes number of logical gates used.
Okay.
Then disadvantages is it is not suitable for when the number of variables involved exceed 4.
Number of variables exceeds more. Okay, fine. Okay, what he said is right. A K-map is a simple method, like a graphical method of simplification without using any laws of Boolean algebra. Right? Very easily you can simplify by plotting the min term or max term in the K-map. Right? But the main disadvantage of K-map method is that, no doubt, it is very simple and it is very easy to get the simplified expression using K-map. But main drawback of K-map is that it depends on the user's ability to identify the patterns that gives the largest size. As you might have seen already, many of you might have experienced the problem in identifying the groups. Like, so it all goes with the user's ability to form the groups. Like how well you can form the groups, it depends on that. So the success of the K-map method entirely depends on what? It entirely depends on what?
User.
Yes. Group. It entirely depends on the user's ability to identify the bigger groups. How we can identify the bigger groups? It depends on that. Right, and also this method becomes difficult to adapt for simplification of 5 or more variables. Right, if number of variables are more, up to 4 variables, yes, it is very easy. Easily we can simplify the given Boolean expression. But when you go for 5 variable or more than 5 variables, definitely the method becomes complex and the solution may be difficult. Hence, we are going for one structured method or algorithmic method of simplification. And that simplification method is called as Cohen-McCluskey method, which is commonly called as QM method. Right? So what is this Cohen-McCluskey method? Basically, Cohen-McCluskey method involves preparation of 2 tables. Like one determines the prime implicants and the other selects the essential prime implicants to get the minimal expression. In fact, I already told you what is the difference between prime implicants and essential prime implicants. Can anybody tell me what do you mean by prime implicant? Yes? What is prime implicant? Yes? Can anybody throw a light on this? What do you mean by prime implicant? Yes? Yes, Akash, what is prime implicant? What do you mean by prime implicant? Yes. What is prime implicant? Yes. Can someone tell me what do you mean by prime implicant? Yes.
Product term.
Say loudly.
Product term.
Product term. All product terms we can't call it as a prime implicant. So what exactly you mean by prime implicants? In fact, in the last class I have explained you about prime implicants and essential prime implicants. When you use the K-map, when you form the different groups, every group can be represented by one product term, and that product term is called as prime implicants. which may be essential or non-essential to represent that particular function. Whenever you form any group, whether that group is redundant or not, or whether it is required or not, every product term corresponding to that group is called as a prime implicant. Whereas only those group which you will be considering for minimized SOP expression, the product term corresponding to those essential groups are called as essential prime implicants. I hope the difference between prime implicant and essential prime implicants is clear. Yes or no? The difference between prime implicant and essential prime implicant, is it clear? Yes. So whenever you form any group, that group can be represented by one product term, and that product term we can call it as what? The prime implicant. But sometimes some groups are redundant, which may not be required. You have to eliminate those and you have to select only minimum number of groups using which you can cover the entire function. Those prime implicants are called as essential prime implicants. Right? So in Cohen-McCluskey method, what we are doing is we are using two different tables here. Instead of going for graphical method, Cohen-McCluskey method is called as tabular method, wherein we will be using two different tables, one to determine the prime implicants and the other to select the essential prime implicants to get the minimal expression. Right? So as you can see here, the Cohen-McCluskey method reduces the min-term expansion, that is standard SOP expression, to get the minimum product terms. Right? So the basic procedure involved in this Cohen-McCluskey method is again similar to the K-map method what we have used. If you come across the term xy plus xy bar, we know that we can take x common, inside the bracket we can write y plus y bar, and that y plus y bar is 1 x and 1 is x. This is what is the prime implicant, and this method we are using, or this theorem we are using in Cohen-McCluskey method also. That is xy plus xy bar, we are using it as x. That means we are going to check, is there any single bit difference or single position difference from one literal to another literal, and then we are going to eliminate certain input variables, and that is how the Cohen-McCluskey method used. So eliminate as many literals as possible from each term, and then use a prime implicant chart to select a minimum set of prime implicants, which when all together are equal to the function being simplified. Right? So first we have to find the prime implicants, then use the prime implicant chart, and from that prime implicant chart you should select the minimum set of prime implicants, and then all those prime implicants should be added together to get the SOP solution. Right? So this particular Cohen-McCluskey method is used only for SOP expressions. Then you may ask, if the given expression is in POS form, what we should do? Always Cohen-McCluskey method will start, or it should be used with SOP expression only. So in order to use the Cohen-McCluskey method for POS expressions, what you need to do? First, the given POS expression should be converted into SOP expression, and already I have explained you how POS can be converted to SOP, or how SOP can be converted to POS. So one thing you should remember, Cohen-McCluskey method uses only SOP expressions. So if the expression is given in POS form, you have to convert it into SOP, and then you should use the Cohen-McCluskey method. Right? That's what is explained here, like how we should determine the prime implicants from the table. Right? So there are different stages will be involved in it. I'll be explaining directly this with the help of one example only. Then only we'll understand like how exactly the grouping can be done, how the literals can be eliminated, and how we can move from one stage to the next stage. Like we'll be getting this structure in stage 1. What is this? I'll be explaining you shortly with the help of example only. Right? Then again in stage 2, we have to follow the similar procedure, and then we can come across the stage 2. You can see this is stage 1 here, and this is stage 2. Similarly, we may have stage 3, stage 4. It depends on the given expression. We have to use this kind of method to eliminate the different literals, and finally we can get what is called as the simplified SOP expression using Coin-McCluskey method. The first step, that stage 1, stage 2, stage 3 chart, what you can see, that is used to get what are called as prime implicants, and this chart which is shown here in the table in this slide is called as the prime implication chart or prime implicant chart. And this prime implicant chart is used to select only the essential one. So in the first step, we are determining the prime implicants using one tabular column, and in the second step, we are using this prime implicant chart to determine the essential prime implicants, and we can get the simplified expression, right? So I'll go to it like directly. I'll take one example, and we'll see how we can eliminate the different literals and how we can simplify the given Boolean equation, right? I hope all of you understood what exactly Coin-McCluskey method is and how it is different than that of K-map. As I said, directly I'll be taking one example and I will be explaining the Coin-McCluskey method. So before that, I want you people to just write down few points about this Coin-McCluskey method, because this is what the procedure we have to follow, and this procedure I will be explaining with the help of example. Is that clear? Is it fine? At least you understood, means what is Coin-McCluskey method, how exactly Coin-McCluskey method is used, I will be explaining you. Basically, Coin-McCluskey method is a what? Tabular or algorithmic method which consists of two steps. In the first step, we have to find the prime implicants, and in the second step, using prime implicant chart, we have to find the essential prime implicants. So basically, it is a two-step process. Right now, you should understand only this much. Hope it is clear. Yes? Right. So write down what exactly you mean by Coin-McCluskey method. Just write down the definition of Coin-McCluskey method. You write down this. It is a tabular. It is a tabulation. It is a tabulation or algorithmic method. It is a tabulation or algorithmic method consisting of two steps. Consisting of two steps. Consisting of two steps. That is finding all prime implicants. Finding all prime implicants. Finding all prime implicants. And using prime implicants chart, and using prime implicants chart, and using prime implicants chart to get essential prime implicants. To get essential prime implicants. To get essential prime implicants. Okay. Right. Now write down the procedure for this. This is very important. And I'll give this procedure in such a way that it should be self-explanatory. And with this procedure, you should be able to solve any given expression. Okay. Procedure you write. First point. List all the minterms in the binary form. List all the minterms in the binary form. I hope all of you are taking it down. Yes or no?
Yes, sir.
Yes, sir.
Okay, good. First point is list all the minterms in binary form. Second point, arrange these minterms. Arrange these minterms according to number of ones present. Just write it down. I will explain all these points with the help of example. Arrange these minterms according to number of ones present. Third point, compare every number in the group, with adjacent group, compare every number in the group with adjacent group, and if they differ by only 1 bit position, place dash in place of differing bits. Place dash like this. Just you have to place a dash. I hope the board is visible now. Place dash in place of differing bits, and also tick mark those mean terms, and also tick mark means like this, and also tick mark those mean terms, and also tick mark those mean terms. Tick mark those mean terms. Next, fourth point. Repeat the process for the resulting columns. Repeat the process for the resulting columns. Repeat the process for the resulting columns, and continue this until no further elimination is possible. Continue this until no further elimination is possible. Right, these are the steps you have to follow for first step. Like, because I said Cohen-Macklusky method is a two-step process. So this first 4 points comes in the first step. Now write the point number 5. Point number 5. List all the minterms in the prime implicant chart as given below. List all the minterms in the prime implicant chart as given below. Prime implicant chart as given below. Right, under that first, or point A you can write under fifth one. Point A you can write. Prime implicants should be represented in the rows. Prime implicant should be represented in the rows, and each minterm in the column. Each minterm in the column. Again, I am repeating, just write it down. When you solve the example, this procedure will be more clear to you people. The prime implicant should be represented in rows and each minterm in the column. That is first point in constructing the prime implicant chart. Then point B you should write X mark, just X cross mark. Cross mark should be placed. Cross mark should be placed in each row to show the composition of rows, that makes prime implicant. Composition of rows that makes the prime implicant. Okay. Then point C, the completed prime implicant chart should be inspected. Completed prime implicant chart should be inspected for columns, containing single X. Containing single X. Such prime implicants are called essential prime implicants. Such prime implicants are called essential prime implicants. And the last point, that is
So
point
please repeat
D.
this point.
Point D. Write the simplified expression using essential prime implicants. Write the simplified expression using essential prime implicant. Using essential prime implicants.
Excuse me, sir.
What happened?
Sir, will you please repeat the C point?
Which point?
C.
Point C.
One before this. Yes.
Okay. The completed prime implicant chart should be inspected for columns containing single X. Chart should be inspected for columns containing single X. Such prime implicants are called essential prime implicants. Such prime implicants are called essential prime implicants. And the point D is write the simplified expression using essential prime implicants. Okay. I know most of you might not be clear with what I have given the procedure, but definitely the procedure will be clear when you solve this particular example. Okay, we'll take one example. Board is visible now. So on.
Yes, sir. It's visible.
Okay. Take down this example. Simplify following Boolean expression. Simplify following Boolean expression. Simplify following Boolean expression using Cohen-Macklusky method or QM method. Using Cohen-Macklusky method. I'll take simple one. This is the expression given, which we need to simplify using Cohen-Macklusky method. Right. So how do we go about this particular example? What I have told, what is the first step? First, whatever minterms are given, you represent those minterms in binary form. So you have to construct first tabular column. As I said, this method consists of two tabular columns. So out of that, the first one you need to construct. So what I should do in this is, you should write the minterm given, and then you should have the binary representation of that given minterm. What are the minterms given? Yes, 2, 6 and 7. These are the minterm given, and they have given 3 input variables, so I have written 3 A, B, C. Right. So what you need to do is, whatever these minterms are given, first you have to represent them in binary form. So how do I represent this 2 here? How I should represent 2 in binary? 3-bit binary form.
0, 1, 0.
0, 1, 0. Then 6 is
1,
1
1,
1
0.
0
1,
1 1 0
1, 1, 0. And 7 is
1,
1, 1, 1. Right. This is what you have to do. Whatever may be the given example, first you write the minterms in decimal, represent them in binary. This is common for each and every example. Then you have to go for first stage, second stage, third stage, and so on. So you should write the first stage. Again, you have A, B, C here. Okay. From here onwards, your actual Coin-McCluskey method start. What is the first step I told? Just read that point number 2 or 3 which I have given to you. One of you read that? Yes? What is that? Point number 2. First one is list all the minterms we have listed in binary form. Right? Then the second one. What is the second point?
Arrange these minterms according
Arrange
to
these
number of
minterms
number of ones present.
according to number of ones present. Means what? This is very important step. You should check each and every minterm. First, you should write the minterm having 0 number of ones, then single one, then 2 ones, then 3 ones, and so on. Now you can see here how many ones are there in this? How many ones are there in this?
1,
1 here,
2,
here.
3.
3.
That means here single one is there, here double ones are there, here 3 ones are there. So you have to write it in the increasing order. Now what order I should write here? In what order I should form? You have to form the groups. First, like minterms having 0 number of ones, then minterm having 1 number of 1, 2 number of ones, 3 number of ones, like that. So first I have to write here what again? 0, 1, 0. And write it, what is that? 2. This is one group. Then 1, 1, 0, that is 6. That is second group. 1, 1, 1, that is 7, third group. I get here 3 groups. Why I get 3 groups here? What is the first group represents here? First group is the minterm containing how many ones?
1,
Yes.
1.
Only
Single one, 2 ones, 3 ones. So I get here 3 groups. Maximum how many groups are possible with 3 variables? Maximum how many groups are possible with 3 variables? 4. You may get one minterm. Say, suppose if you get here 0, 0, 0, where you would have placed that? You would have placed 0, 0, 0 at the beginning, because that is the first group having no ones. Is that clear? This is very important stage, first stage. You have to make the groups based on number of ones present. Right? This is first group. Now, how do you go to the second stage? Second stage is very important. Read the point number 3. What is given there? One of you can read that point number 3. Yes? Point number 3, one of you can read.
compare every number in the group with adjacent group.
So how many groups are there now? Here.
3,
How many groups we have? 3 groups, right? So each element in the first group should be compared with each element in the second group. Then each element in the second group should be compared with each element in the third group. So here we have 3 groups. So in the next stage we may get maximum 2. Maximum we may get 2 or a single. That's what you have to do. Now how to do that grouping or comparison? You should start comparing this with this. 0, 1. Whether it is same or different?
different,
Different. 1 and 1?
same,
0 and 0?
same.
Same. That means how many bits are changing between first group of first element and first element of second group?
1 bit,
1 bit.
Only 1 bit is changing. So what you should do is this and this should be combined here, and wherever the bit is differing, what I have to write? 0 and 1. When that bit differs, you have to write
dash,
dash 1, 0. And how I got it? By combining 2 and 6. By combining 2 and 6, I got dash 1, 0. Right? That comparison is done. I have compared first and second group. Now, second and third group you should compare again. Right? So how we should do the comparison of second and third group? You should check here again. This 1, 1, 1, 1, then 0, 1. Right? 1, 1, 1, 1, 0, 1. So this is same, different. So can I combine 6 and 7?
yes,
Yes, sir.
So again I should take 6 is already ticked, 6 and 7 should be ticked, and that should be taken here as what? 1,
1
1,
1 dash
Dash.
dash
and how I got it? By
6
combining
and 7.
6 and 7. So all the three groups I checked. Next you have come to the second stage, and this is your A, B, C. Now you should check whether third stage is possible or not. For that, what you should do? Again, you should check whether there is a single bit difference. Now here dash is there, one they are different. It is same. 0 and dash it is different. So no further what? No further elimination is possible. No further elimination is possible. So what you need to do is you have to stop in the first step there itself. That is what is called as finding the min terms. So we got there 2 min terms now, right? So you have to check whether those 2 min terms, out of those 2, whether both are required or any one is sufficient to cover the term. Is that clear? This is first step. Now second step, we need to complete what? Or we need to draw a prime implicant chart. So how I should draw the prime implicant chart? I'll just try to write here, just check whether it will be visible for you people or not. Yes. I will write a prime implicant chart here itself. Here I have to write prime implicant, right? That is the prime implicant, and min term. Right? How many min terms we are having? Those in column you should write 2, 6, and 7. And how many prime implicants we have got from the previous step? This is first step. From this step, how many prime implicants we have got? Prime implicants means all those which are not ticked in stage 1, stage 2, stage 3. Here all are ticked, but these 2 are not ticked. So these 2 are called as what? Prime implicants. So those prime implicants you have to write here. That is C dash 1 0, which is 2 comma 6, and this is 1 1 dash, that is 6 comma 7. Now dash 1 0 means what? A is eliminated here, and what you are having? B, C bar. Here C is eliminated, and you are having A, B. I hope it is clear how I have written this. Is that clear?
Yes, sir.
A, B, C is dash means that particular variable is eliminated. Here A is eliminated, here C is eliminated. Here B is present, 0 means C bar is present. Here both are 1 means A and B is present. Next, what we need to do is this particular min term, it covers this particular prime implicant covers which all min terms? This is called as prime implicant, DC bar. It is covering which min terms? Which min
2 and
terms?
6. 2 and
2
6.
and 6. So you have to put cross mark here in 2 and 6. Similarly, this min term covers which prime implicant covers which min terms?
6 and 7.
6 and 7. Is that clear? 6 and 7. This is clear how to put the X marks. Is that clear?
Yes, sir.
Yes or no?
Sir, clear.
What is the next step then? That is called as prime implicant chart. Now what you have to do after constructing the prime implicant chart, you have to inspect for a column containing.
Single X.
Are there any columns which contain single X?
Yes, sir.
You can see here, this is first column. How many X are there in it?
1.
1. So you should encircle that. Here 2, leave it. Here 1 X. So you should encircle the single X. After encircling the single X, you should check which particular prime implicant covers this. Who is covering this X? This. So this is called as what? Essential prime implicant. Similarly, who is covering this? This. So this is also called as essential prime implicant. Now this particular prime implicant covers 2 and 6. This covers 6 and 7. So all the 3 are covered. Hence I can write the final answer F as BC bar plus AB. Right? This is the final answer, which you can verify using K-map. You can quickly write the K-map for this, and you can try to verify your answer. Yes, I don't know how many of you have understood this. Yes,
Understood, sir.
one by one, who has not understood, you can ask me so that your doubts will be clear. Entire thing on the board is visible, no, now? Yes?
So can we compare first and third part in the third row?
Hello? Just check. If you have any doubts here, you can ask me first.
Hello, sir. Hello.
Yes, somebody was asking something. I think Adnan, you had some doubt?
Yes, sir. Can we compare first and third part?
No,
First
no,
and
no.
third,
That's what you read that procedure, what I have given there. What I have mentioned in the procedure?
adjacent.
Adjacent groups only. Because we need to check whether there is a one bit change. I told you now, basic identity or a property or a theorem, what we use here is xy plus xy bar is equal to x. That is the basic theorem that is used in this particular method. Yeah, any other doubt? A very good question, Adnan. Anybody is having any other questions, you can ask. Yes? That means I think most of you have not understood it. I am not seeing any yes, yes or no, no in the chat box also. Shreya, you understood this method?
Yes, sir.
Can you explain what we should do? With the
Yes,
help
sir.
of this example itself, try to explain what is Cohen-Maklowski method is. In fact, this is very important method, compulsory 10 to 12 marks question you are going to get in your exam also. Yes, Shreya, just explain in brief.
So first we need to write the main terms
Okay.
which are given, and then the binary representation of those main terms.
Yes.
And then we should arrange those main terms in the numbers, means like in the number of ones.
Okay. First, what you should write?
The number which consists less number of ones we should write.
Okay.
Then after that, in second stage, we should compare each digit
Okay.
to the second one. And if
Okay.
the digit is same, we should write it as it is. If it differs by one bit, we should write dash.
Okay. Then?
Then we should draw a chart, prime implicant chart,
Okay.
in which prime implicants we should write down,
Okay.
and the min terms of those, and then
Yes.
we should write those which prime implicant consist which all min terms, like
Okay.
2 and 6 for the first one.
Okay.
Then we should mark it as x.
Hmm. Next. That's all?
No, sir, we should mark it as x.
Okay.
Then we should encircle it.
Which x you should encircle?
In if the column consists only single x, then we should encircle it.
Exactly. And the column, row containing that encircled x is called as what?
Essential prime implicant.
Actually, you have already prime implicants. Out of this, you are finding which are
Essential.
essential one. And to find those essential one, you need to do what? That encircling of x.
Yes, sir.
I hope it is clear with everyone. Any doubts? Because this is very important method. If you have understood, say yes. Then we'll proceed further. Yes? Everything is clear? All of you. Namita? Good, good. I'm seeing so many yes there. Good, very good, very good, very good. Okay, if there are no doubts, then we'll proceed with the next example. Because I have taken to start with very simple one. I'll take one example with 4 variables now. Can we move forward? Yes?
Yes, sir.
Yeah, you can take down this example then. Second example, f of a comma b comma c comma d. Shall I clean the board? You can take down this f of a comma b comma c comma d equal to sigma m 0 2 3 6 7 0 2 3 6 7 0 2 3 6 7 8 10 8 10 12 13. Yes, 8 12 13. Yes. Is that example visible properly? Yes. Okay, what is the first step now? What I need to do? Yes. Yeah. What I should do first? Yeah, someone should help me. Aniket? Aniket?
Yes, sir. Yes, sir.
Yeah, you guide me what I should do. What is the
So
first
first we have
step?
to write down the mean terms given.
Yeah. I will write all the mean term given. What are the mean terms given there?
So 0, 2,
0, 2,
3, 6,
6, 7,
7,
8,
8,
10,
12,
12.
13.
The next, what I need to do?
So binary representation.
Binary representation. How many variables are there?
4.
Oh, you should give a little bit space here to put the tick mark. Right? Yes. What I should write first? 0 is nothing but
0, 0, 0, 0.
0. 2 is 0, 0,
0,
1,
0,
0. 0, 0, 1, 1. 0, 1, 1, 0.
0.
Then 0, 1, 1, 1. 1, 0, 0, 0. 1, 0, 1, 0. 1, 1, 0, 0. 1, 1, 0, 1. Right? Binary representation we have done. Then we should go for first stage, wherein we need to write again these 4. Here also I will keep little bit space, and I can do that. Fine. Okay, how I should construct the first stage? That is very important part now. Whatever the given data I have written, I think everybody will be able to do this without any problem. Yes or no? Yes, Richa?
Yes, sir.
Yes, sir.
In this point, there are no issues at all. Whatever is the given thing, you have to write it as it is. Write the mean term, represent them in binary form. Now, from here onward, your actual coin matrix method starts. So, what you need to do in the first stage? You have to arrange these mean terms according to what? Number of ones present. So, what I should write first? First, what I should write?
0, 0, 0, 0.
0, 0, 0, 0, which is that mean term 0, and this will be the one group, right? No number of no ones present at all. Next we have to write 1 ones. Where all 1 ones are there? So this I have taken there. The next I will write this as what? 0, 0, 1, 0. Then anything else? Yeah, this one and 8, 1. This is 2. And 1, 0, 0, 0, that is 8. So I will get one more group. This group contains 0 ones. This group contains 1 ones. Now we should get a group of 2 ones. So I will write this 3. that is 0, 0, 1, 1. Then 0, 1, 1, 0, that is 6. Then this I have written. Then 1, 0, 1, 0, 1, 0, 1, 0, that is 10. Then 1, 1, 0, 0, that is 12. This is the third group, contains 2 ones. The next, what I should write? The group containing how many ones? 3 ones. This one is there, 0, 1, 1, 1, that is 7. Then 1, 1, 0, 1, that is 13. So all of this we have covered here in the first stage, but we have put it into different groups. How many groups we have formed here? 1, 2, 3, 4. Here we got 4 groups. With 4 variables, maximum you can get 5 groups. Here one more group is missing because we don't have min term containing 4 ones here. If you would have that 15 also, then you would have had one more group. So here we got now how many groups? How many groups? Yes?
4.
How many groups we got? 4.
4 groups.
4 groups.
I think this is clear. First stage.
Yes.
Any doubts? If you have any doubts, you can ask me, because now we are going for the second stage, which is very important one. I will write here it as second stage, A, B, C, D. You put little bit more space because you have to combine this and write now. So here you need some additional space. You can make a provision for that. Okay. Now this is very, very important. What we need to do? This 0 should be compared with what? 2 and 8 and check whether grouping is possible or not. Then 2 should be compared with 3, 6, 10, 12. 8 should be compared with 3, 6, 10, 12. Then 3 should be compared with 7 and 13. 6 should be 7, 13. 10 should be compared with 7, 13. 10 should be compared with 7, 13. And accordingly, you should check whether new groups are possible or not. Is it fine? Till this point, any doubt? Because this is simple. Here we have not done anything. Still, we have not started the process of elimination. Just we have written the given data as it is. Then we have represented the same data in different groups. Now the next stage, second stage, we are getting check whether can we combine 0 and 2. Here it is 0, 0, 0, 0, 0, 1, 0, 0. So how many bits are changing in 0 and 2?
1
One bit.
1 bit is changing. So what I should write here?
0, 0 dash.
You can see here, you should put tick mark. 0 and 2 should be combined and it should be written as 0, 0,
Dash 0.
dash 0. And inside the bracket, you should write what? 0, comma 2. Now check whether can we combine 0 and 8 also? Can we combine 0 and 8?
Yes.
Yes. What I should write that? Dash
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 0
0, 0, 0.
0. And that
0
is
and 8.
0, 8. Done. So comparing first and second group, I got one more group there. Is that clear? Now I have to compare second and third. And when you are combining, don't forget to tick mark. That plays a very important role there. Because in the next step, you will understand what is the significance of that tick mark. So you should not forget to tick mark. Whichever you are combining, you have to put the tick mark there. Next, can I combine 2 and 3? You can see here 0, 0, 0, 0, 1, 1, 0, 1. This only one will be changing. So 2 and 3 can be combined, and I can write this as 0, 0, 1, dash 2, comma 3. Then check whether can be combined 2 and 6, 0, 0, 0, 1, 1, 1, 0, 0. 2 and 6 also can be combined, and I can write this as what? 0, dash 1, 0. So 2 and 6 is also combined. I should take mark. Then check 2 and 10. Is it possible? 0, 1, 0, 0, 1, 1, 0, 0. So 2 and 10 also can be combined. And I can write that as what? Tell me, Aniket. Dash.
So dash 0, 1, 0.
1, 0. This is got by combining 2 and 10. Then 2 and 12. Is it possible? 0 and 1 is changing, 0 and both are changing. No, 2 and 12 is not possible. Is that fine? Next, check 8 and 3, whether it is possible. 8 and 3. Can I combine 8 and 3 now?
No, sir.
No. Then
No,
check
sir.
8 and 6. Different, no. Then 8 and 10, same, different, same. So 8 and 10 can be combined, and you can write that as what? 8 and 10 is what? 1, 0, dash, 0. And that is 8, 10. Even if it is already ticked, you have to write that here, and you should put the tick mark, right? Then what about 8 and 12? Is it possible? Yes. 8 and 12, when I combine, I get 1 dash 0, 0, and that is 8 and 12. That completes second group. By comparing second and third group, I got their second group. What is next now? Yes, Adnan, help me further. What I should do next?
Compare third and fourth group.
Third and fourth group. So check whether 3 and 7 can be combined. Same, different, same.
Yes, sir.
So can I combine? Yes. And what I should write? 0 dash 1 1. 3 comma 7. Don't forget to tick 7. Then check 3 and 13. Can I do? No. 3, 13. No. Then check 6 and 7. Is it possible? Can I combine 6 and 7?
Yes, sir. Yes, sir.
6 and 7, it is possible. So what I should write? 0, 1, 1 dash.
Dash.
6, 7. Then 6 and 13, different, same, different, no. Then 10 and 7, different, no. 10 and 13, same, different, no. 12 and 7, different, no. 12 and 13, yes. 12 and 13, what I get? 1, 1, 0, dash. 12, comma 13. Right? So this is how I have completed second stage. And I got how many groups now? How many groups I got?
3 groups.
3 groups. Now we have to go to third stage here. Because more than one groups are there, so there may be possibility of combining them again. Third stage, A, B, C, D, you should write. Now, henceforth, the comparison will be very simple. You need not compare each and everything. Take the first element here. First element, check where the dash is there. Here dash is there. Check at that place if there is any dash in this next group. Here dash is there. Right? Corresponding to the dash, here dash is there. Now you check only these two. Can be combined. Can be combined? Here it is what? 0 and 1. Different. 0, 0 same. Dash, dash same. 0, 0 same. So definitely I can combine what? 0, 2 and 8, 10. And I can write that as dash 0 dash 0. And I got it by combining 0, 2, 8, 10. Next, check this. Here dash is there. Can be combined 0, 8 and 2, 10. Dash 0, different 0. Yes. 0, 8 and 2, 10 can be combined and we get dash 0 dash 0. Sorry, dash 0 dash 0. That is 0, 8, 2, 10 or 0, 8, 2, 10. That is same. Right? So this and this comparison is done. You need not bother about the other thing. Now check comparison of this and this. When you are doing comparison of this and this, check this now. Dash is here. Here is there. Check whether we can club this. It is not possible with the other one. So 0 and 0 same. 0 and 1 different. 1 and 1 same. So 2, 3 and 6, 7 can be combined. And what I can write? Tell me what I can write. This one is completed. 2, 3. That is 0. Then
Dash.
Dash.
0 dash
1 dash.
1 dash. This is 2, 3, 6, 7. 2, 3, 6, 7. Okay. Next, this can be combined with this. Here 0, 0, 1, 1 low. Done. Next, take this. This check with this. Can it be combined? 2, 6, 3, 7. Same, different. Yes. 2, 6 and 3, 7 can be combined. And I can write again 0 dash 1, 0, 2, 6, 3, 7. Next, check this. This dash, here no dash is there, so this cannot be checked with anything else. Here dash is there, but here no dash, so this also cannot be checked. Now here dash is there, here dash is there, but here both the bits are differing, so we can't what? Combine that with anything, right? That is how we got in the seconds, right? I hope the first step is clear. All of you understood this? Yes?
Yes,
All of you
sir.
understood this or not? Okay.
Yes, sir.
Now, how many prime implicants you are going to get? Can we go further again? Fourth stage also is possible. Here is fourth stage possible. You can see here. Here dash is there, here no dash. Here dash is there, here no dash. That means further comparison is not possible only. We need to stop there only. But again, if it is possible, you could have gone for what? Fourth stage also. Is that clear? Okay. So first step is over. What is the second step now? What is second step? You need to construct prime implicant chart. So what are prime implicants you are going to write in that prime implicant chart? All those from this table which are not ticked should be taken there. That means I need to take this. This and this is same. Only one should be taken. Don't write both, because 0 to 8, 10 and 0 to 10 both are same. You can write any one out of these two, right? And out of these two, any one. So 1, 2, I should take. There should be 2 rows in the prime implicant chart. Only 2 rows, or any other thing we have to add in that? Yes? Because
So this
how many
last-
rows should be there in the prime implicant chart? But before that, how many columns should be there in the prime implicant chart? Because next you are going to write the prime implicant chart. Then how many columns should be there? How many columns should be there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 columns you have to make corresponding to each mean term. Then I am asking how many rows? 1 row, second row, then anything else?
The last
Yes,
row.
this is third row, then fourth. All those from this which are not ticked. 8, 12 is also not ticked. 12, 13 is not ticked, and these are not ticked. So 1, 2, 3, and 4. 4 terms should be there, or 4 prime implicants should be there in the what prime implicant chart. I hope all of you understood this. Of course, it is a lengthy process, but very interesting, and very easily you can get the answer, and you can verify your answer by K-map method. Right? So I want you people just try to construct the prime implicant chart and try to find the essential prime implicants. If you get it, well and good. If not, we will continue this example in the next class. So before we close, if you have any difficulties, you can ask me. Do you have any difficulties? Hope all of you understood the prime the Cohen-Maklowski method. Again, I am repeating, it is a very important method of simplification of Boolean expressions. If you have any difficulties, any doubts, you can ask me. Or else, if there are no difficulties, we'll close the class for today.